Hello, space enthusiasts and curious minds alike. Today, we're diving into the mysteries of Venus, often dubbed Earth's evil twin, but how similar are they really? Recent research suggests that Venus might mirror our planet more than we ever imagined. Buckle up as we explore these fascinating findings in today's video. Exciting new research has revealed surprising similarities between Earth and its often maligned cosmic neighbor, Venus. While Venus currently shows no signs of the tectonic activity that characterizes Earth, its landscape tells a story of a turbulent past. Features such as faults, folds, and volcanoes paint a vivid picture of a planet that was once alive with geological movement. This study focuses on remarkable formations, known as tesserae, on Venus's surface, which suggest that billions of years ago, Venus experienced intense tectonic activity. This activity may have been akin to the forces that shaped Earth's earliest continents, offering a fascinating glimpse into the dynamic history of our neighboring planet. Fabio Capitano, the research leader from Monash University's School of Earth, Atmosphere, and Environment, expressed surprise in a recent statement, revealing unexpected complexities on Venus. Despite its blistering surface temperatures of 860 degrees Fahrenheit and a seemingly stagnant tectonic landscape, Venus hosts remarkably intricate geological structures. We did not anticipate finding such sophisticated geological features on a planet without active plate tectonics, Capitano noted. This groundbreaking study, conducted in collaboration with NASA, is reshaping our theories on planetary evolution. Plate tectonics, the dynamic theory that explains how the rigid outer shell of a rocky planet's crust, known as the lithosphere, is divided into several large, moving plates, uniquely characterizes Earth. These plates glide, collide, and shift against each other, continuously reshaping our planet. This phenomenon, so far, appears to be exclusive to Earth. Venus presents a stark contrast with what's known as a stagnant lid, a single, immobile plate that shows minimal movement. Yet, the tectonic history of Venus is a hot topic among scientists. Many theorize that Venus might have once exhibited some tectonic activity before transitioning to the static state we observe today, sparking debates and driving further research into how planets evolved their surfaces over eons. To delve deeper into Venus's mysterious tectonic past, Capitano's team turned their attention to the Ishtar-Terra Highlands, a striking feature on Venus's otherwise quiet geological landscape. Described in a recent Nature Geoscience publication, the Ishtar-Terra Highlands consist of a massive crustal plateau roughly the size of Australia, soaring about 2.5 miles, 4 kilometers high, akin to Earth's Tibetan Plateau. Surrounding this are mountain belts that reach elevations of approximately 6.2 miles, 10 kilometers, surpassing even the Himalayas. Beneath these impressive structures lies a thick crust comparable to Earth's ancient cratons. On Earth, such grand formations are typically the product of tectonic plates colliding. However, Venus's surface is predominantly inactive. This paradox raises intriguing questions. How did such dramatic landscapes form on a planet with a dormant crust? Capitano's team suggests that these formations could not only signify a geologically active past similar to Earth's, but also potentially unlock secrets about the geological evolution of rocky planets across the cosmos. To unravel the geological enigmas behind the formation of the Ishtar-Terra Highlands, scientists turned to advanced computer modeling, enhanced by critical data from NASA's Magellan mission. Launched in 1990, the Magellan spacecraft achieved a historic first by imaging Venus's entire surface, providing invaluable insights into the planet's mantle and lithosphere. These observations have been pivotal in tracing the thermal, chemical, and mechanical changes over time. Armed with this comprehensive data, researchers have crafted detailed scenarios to explain how the spectacular Ishtar-Terra Highlands might have formed, shedding light on processes that could reshape our understanding of planetary geology. The team meticulously compared their models' results with the dynamics of Earth's mantle using well-established scientific methods. They also explored variations in the strength of the lithosphere, taking into account Venus's significantly higher surface temperatures. This innovative approach enabled a comprehensive comparison of mantle dynamics and lithosphere behavior, blending previous models that had separately focused on either planetary tectonic features or different crustal states from mobile, like Earth's, to stagnant, like Venus's. The findings suggest a fascinating process by which the plateaus could have formed. The planet's surface thins and melts under the strain of its own low strength, causing molten rock to rise and create elevated regions. As time progresses, this stretching activity diminishes, the mantle's resistance increases, and the surface begins to cool, ultimately leading to the formation of high plains encircled by dramatic mountain belts. This process mirrors the early formation of the ancient tectonic cores, known as cratons, on a much younger and hotter Earth, long before the advent of plate tectonics. This comparative insight into Venus and Earth's past adds a profound layer to our understanding of planetary evolution. Capitano shared his excitement about the new findings, stating this discovery offers a captivating new perspective on Venus, unveiling potential parallels with early Earth. The similarities between the features we observed on Venus and those of Earth's ancient continents suggest that Venus's geological past might mirror Earth's more closely than we ever imagined. He expressed hope that by exploring these analogous features on Venus, scientists could unravel mysteries surrounding Earth's formative years. Capitano concluded with an optimistic outlook on the future of planetary exploration. Our findings have set the stage for upcoming missions to Venus, including DAV-INC, IV-EIR, IT, ASEA, and Envision. These missions are poised to deepen our understanding of Venus's geological evolution and its ties to our own planet. First, let's talk about the atmosphere. Venus boasts an incredibly thick atmosphere, composed mainly of carbon dioxide with clouds of sulfuric acid, making it an extreme greenhouse world. Initially, scientists believed Earth could never mirror this hostile environment. However, studies suggest that early Earth might have had a much thicker CO2 layer than today, possibly giving us a glimpse into our own planet's ancient past. Moving on to geology, Venus is a volcanic wonderland with thousands of volcanoes, some still potentially active. Similarities in volcanic features suggest that both planets share a common geological history. Researchers are exploring how Venus's surface might provide clues about Earth's tectonic activities before the rise of life, offering a window into conditions that could have been. Water, or the lack of it, is a defining feature of Venus. Although now a dry, scorched world, there's evidence that Venus might have once held significant amounts of water, perhaps even oceans. This challenges our understanding of Venus as merely Earth's drier counterpart and hints at a potentially Earth-like climate in its distant past. Earth is shielded by a magnetic field, which protects us from solar winds. Venus lacks this feature, leading to severe atmospheric stripping by solar radiation. The question arises, did Venus once possess a magnetic field that made it more Earth-like in terms of habitability? Investigating this could reveal crucial insights into how planetary environments evolve over billions of years. Finally, studying Venus does more than satisfy scientific curiosity. It provides a cautionary tale about the potential future of Earth's environment. Understanding Venus's greenhouse effect on steroids could offer critical lessons in managing our own climate challenges, possibly preventing an earthly descent into a Venus-like scenario. Venus is known for its extreme surface pressure and temperatures. With a surface pressure 92 times that of Earth and temperatures hot enough to melt lead, it's a hellish environment. Scientists believe understanding these extreme conditions can help us better grasp the upper limits of habitable environments and the dynamics of greenhouse effects. Venus has unique geological features, such as tesserae, highly deformed regions of the planet's crust. These features have no direct equivalent on Earth. By studying these formations, scientists hope to understand the geological processes that shape rocky planets, offering clues about Earth's geological history and the formation of continents. Unlike Earth, Venus does not have clear evidence of plate tectonics. This raises intriguing questions about how tectonic activity might start or stop on a planet. Understanding why Venus lacks plate tectonics can shed light on the conditions necessary for such geological processes to occur and persist on Earth. Venus and Earth started with similar building blocks, yet their atmospheres evolved drastically differently. By examining Venus's atmospheric composition and changes over time, scientists aim to understand how different factors, such as distance from the Sun and volcanic activity, influence atmospheric evolution. Venus's clouds, primarily composed of sulfuric acid, create a thick, reflective layer. Studying these clouds can reveal a lot about atmospheric chemistry and weather patterns. Understanding Venus's extreme weather conditions could help refine models of Earth's climate and weather forecasting. Although Venus's surface is inhospitable, recent studies have suggested the possibility of microbial life in its cloud layers, where conditions are less extreme. If life exists or ever existed on Venus, it would revolutionize our understanding of life in the universe and the resilience of organisms in extreme environments. Venus has an extremely slow rotation, taking 243 Earth days to complete one rotation, and it rotates in the opposite direction to most planets in the solar system. This unique characteristic can help scientists understand the diverse rotational dynamics of planets and how such factors affect planetary environments. Venus is often cited as an example of a runaway greenhouse effect. By studying Venus, scientists hope to understand the mechanisms that could potentially lead to such a scenario on Earth, providing valuable insights into preventing similar outcomes on our planet. The surface of Venus is covered with numerous impact craters, which can provide a record of the planet's geological history. By analyzing these craters, scientists can gain insights into the age and development of Venus's surface and compare it with Earth's impact history. Venus features a massive swirling polar vortex at its poles. This vortex is unlike anything seen on Earth, offering a unique opportunity to study atmospheric dynamics and extreme weather patterns, which could improve our understanding of similar phenomena on our planet. Venus has incredibly strong winds at high altitudes, reaching speeds of over 200 miles per hour. These super-rotational winds can teach us about atmospheric circulation patterns and energy distribution within a planet's atmosphere, with potential applications to understanding Earth's jet streams and wind systems. The ionosphere of Venus, a layer of charged particles, interacts directly with the solar wind due to the lack of a magnetic field. Studying these interactions can provide insights into how solar wind affects planetary atmospheres, which is also relevant to understanding Earth's interactions with space weather. Past and ongoing missions like ESA's Venus Express and JAXA's Akatsuki have provided invaluable data on Venus's atmosphere and surface. These missions have expanded our knowledge and will continue to inform future explorations, highlighting the importance of robotic missions in planetary science. NASA's planned missions, such as DAV, INC, I+, and VERIT, AS aim to deepen our understanding of Venus. These missions will focus on analyzing the atmosphere, mapping the surface, and studying geological processes, offering the potential for groundbreaking discoveries about our neighboring planet. Comparing Venus with Earth and Mars allows scientists to practice comparative planetology, which involves studying similarities and differences among planets to understand their histories and evolutions. This field helps refine our models of planetary formation and habitability across the universe. Venus has been observed for millennia, from ancient astronomers to modern telescopes. Its brightness and proximity made it a focus of early celestial studies. Understanding the historical context of Venus observations can provide a richer perspective on how our knowledge of the planet has evolved over time. Due to its thick cloud cover, Venus's surface is mapped using radar. Missions like Magellan used radar to penetrate the clouds, revealing the planet's topography and surface features. These techniques are crucial for exploring other cloud-covered or distant celestial bodies. The presence of sulfuric acid in Venus's atmosphere creates a unique chemical environment. Studying how sulfuric acid forms and behaves can offer insights into chemical processes that might occur on other planets and even on Earth under extreme conditions. Although detecting seismic activity on Venus is challenging, understanding its tectonic and seismic behavior is vital. Venus could provide a different model of planetary quakes, offering new perspectives on how geological activity varies across the solar system. Venus's lack of a magnetic field leads to significant atmospheric loss to space. Studying this process helps scientists understand atmospheric retention and loss, which is crucial for assessing the habitability of exoplanets and the long-term stability of planetary atmospheres. The extreme greenhouse effect on Venus serves as a natural laboratory for studying runaway climate change. By examining Venus, scientists can develop better climate models for Earth, improving predictions and strategies for mitigating global warming. The equatorial region of Venus offers a unique environment for study. By focusing on equatorial dynamics, researchers can better understand atmospheric circulation patterns and surface features that differ from the polar and mid-latitude regions. Venus has long been a popular setting in science fiction, often depicted as a lush paradise or a harsh dystopia. These fictional portrayals reflect our evolving understanding and imagination about the planet, influencing how the public perceives space exploration. While currently inhospitable, some speculate about the potential for human exploration or even colonization of Venus's upper atmosphere, where conditions are more Earth-like. Concepts like floating cities or research stations in the clouds of Venus push the boundaries of our aspirations in space. Understanding Venus's hostile environment helps inform planetary protection policies. By knowing what extreme conditions life might survive, we can better protect Earth from potential contamination during interplanetary missions and ensure safe exploration practices. Venus serves as a valuable comparison for studying climate dynamics. Insights gained from Venus's climate system can refine our understanding of Earth's weather patterns, long-term climate changes, and the impact of atmospheric components on planetary temperatures. Evidence suggests that Venus may have had conditions suitable for life billions of years ago. Exploring this past environment helps us understand the potential for habitable conditions elsewhere in the galaxy, guiding the search for life on exoplanets. Studying Venus's unique characteristics contributes to our understanding of solar system formation. Venus's similarities and differences with Earth and other planets help scientists test and refine theories about how planetary systems develop and evolve over time. Venus's proximity to the Sun exposes it to intense solar radiation, influencing its atmospheric and surface conditions. Studying this impact helps scientists understand the effects of solar radiation on planetary atmospheres and informs the search for habitable zones around other stars. Research on Venus drives advancements in planetary science, from developing new technologies for space exploration to refining scientific theories about planetary processes. These advancements have broad applications, benefiting various fields of science and technology. The exploration of Venus highlights the importance of international collaboration in space science. Missions from different countries, like NASA-ESA and JAXA, contribute to a collective understanding of Venus, showcasing the benefits of shared knowledge and resources. Venus exploration engages the public and inspires future generations of scientists and engineers. Educational programs and outreach efforts related to Venus help foster a broader interest in space science and encourage young people to pursue careers in STEM fields. Studying Venus enhances our search for exoplanets by providing a template for understanding rocky planets in other star systems. By comparing Venus with exoplanets, scientists can better identify potentially habitable worlds and understand their climatic conditions. Venus is known for its high albedo, meaning it reflects a large portion of the sunlight that hits it. This property makes Venus one of the brightest objects in our sky. By studying this reflectivity, scientists can gain insights into the planet's atmospheric composition and cloud structures, which in turn helps improve our understanding of planetary albedo and climate on Earth. The Pioneer Venus missions of the late 1970s and early 1980s provided some of the first detailed data about Venus's atmosphere and surface. These missions laid the groundwork for our current understanding and highlighted the importance of continuous exploration and technological advancement in space missions. Despite the lack of plate tectonics, Venus exhibits signs of significant geological activity, such as coronae large circular features formed by volcanic and tectonic processes. Understanding these features helps scientists study the geological processes that can occur on planets without plate tectonics, offering a broader perspective on planetary geology. The interaction between Venus's atmosphere and solar wind provides a natural laboratory for studying space weather phenomena. Insights gained from these studies are crucial for protecting satellites and space missions from solar radiation and understanding its impact on planetary atmospheres. The Soviet Union's Venera missions were the first to land on Venus, providing groundbreaking data about its surface conditions. These missions demonstrated the feasibility of landing on and studying a hostile planetary surface, paving the way for future exploration efforts. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.